Hello everybody, I like to walk you through a couple of different configuration scenarios of Tesla coils, and also want to walk you through configuration via TMT. Tesla is a magnifying transmitter. There are configurations which have not been shown in that way. There are standard configurations which are applied everywhere, but I will look beyond that and will go through different combinations and what you can achieve with them. So to have a baseline, let's start from scratch. Let's just tune the secondary. Here you see it's in a setup between the primary, so that has not a big influence, only a marginal influence. I connect on the bottom line. You see only the positive side of the function generator, and have the oscilloscope on channel 1 just in the vicinity. And if I set it up like that, it's on 1214 megahertz. Goes in here, as you can see. If I go out of here, it's completely gone. So that's a good thing about the digital one, it's much more precise. So here you can see that has the highest rate, 1.220 megahertz. So now I take it to the next level. That means I gonna drive the primary. No top load, nothing, still the secondary in place. So I would assume it should resonate at the same frequency, but there might be a small difference. So let's have a look. I have at that time I have the oscilloscope directly connected. It might have a small influence as well. Let's have a look. So I'm here at the moment at 11199. Go up. We had 1220. As you can see, I get a higher peak. I get the most peak here at 1249. Yeah, 1249 megahertz. So slightly higher connected. Now I have connected it to Earth, and guess what? Our complete tuning is down the drain. So if you connect to Earth and you have adjusted your frequency according to your measurement for the secondary coil, and that's your frequency you want to work with, forget about it. Once you're connected to Earth, it's all gone. Let's have a look. So as you can see, 1.239, there's nothing. I have nothing connected anymore. There's no Q. So here it starts slowly. You see slowly at 969. So it goes up here, and literally here around this mark, that is max. So I have here at 718, yeah, almost lost half of the frequency, and the Earth connection did slow down my frequency quite a lot. Let's have a look at how strong it is. So that's connected directly at the moment. So that says something about 285 volt. Okay, so far so good. We have no top load. Shall we add a top load? Let's see what that does. Having the top load not connected, I mean, it's nothing miraculous here. You probably all know that, and sorry if I bore you, but you will see later on it's becoming quite interesting. So here we go back to the same frequency. It's nothing, of course. I'm adding capacitance and resistance. And the logical consequence is the frequency is dropping again. Let's go back here. I think that's about it. 530 kilohertz. So 530 kilohertz. Here I have my peak again, and the voltage around approximately the same for 10 volt. Well, very important, the output here is high impedance, and the voltage, okay, can be applied to 20 volt. I will do that later on, but it's high impedance. That means there's almost no power on the output. So that is now our current setup. It's a standard configuration. As you see, we have a Tesla coil, we have a primary, we have a secondary, we have earth connection to the back, and we have a top load on the front, and that's a traditional setup. Please bear in mind we have now 532. If you consider to transmit via a specific frequency to the ground, do your measurements before, you have to at least twice the frequency on the secondary in order to be just in the range of it. But it becomes quite tricky. You probably have to deal a little bit more. I'm not sure if there's any calculation existing which gives you any value how much frequency is reduced when you connect to ground, because that's a direct connection. It is not a connection via a capacitor. There is no coupling capacitor in between, so that becomes a little bit difficult and can probably change from area to area based on your ground connection. Let's take it to the next level. Now, that should be familiar to most of you who have watched my videos. We have here a traditional non-grounded bipolar Tesla coil. That means I have a balanced connection on both sides with the same impedance, with the same capacitance as top loads, and we have it all in the middle. Let's see, put it here in the middle. So now we'll see what's frequency. What would you expect would happen with the frequency now that I removed earth and added a top load? Is it gonna stay? If it goes gonna down, or will it go the frequency up? So those of you who think the frequency will go up, you are right. Let's have a look. So we go back to our 530 we had. I go up in the frequency, and here you see at 800, that's quite nice. The frequency up. Also the power level is a bit lower because now I'm radiating on both sides. That means it's not on one side anymore and it's not grounded anymore. So if I want to get the full power of the system, I have to combine now both sides. Now that is now a very interesting combination, and now let's move on to the interesting part. That is the TMD setup. I have now added a couple of more components. Let's have a look what we have here. Yes, that is a nice mid-size Tesla coil I did build. And please, dear coilers, don't get too excited. I'm not firing this one up. This one was a one-off I did build for my son to show him how nice it is to have a couple of feet of sparks. But the smell was tremendous. We had a couple of days we couldn't get that smell out of the house anymore. So no, this one is very good for testing. Here I use the primary. I have some special setup. So I have also, and hopefully it will not be too annoying, I have frequency modulation on the signal generator. Reason being is that you get an audible feeling of the tuning as well. So what I'm going to do is I'm taking the input side, output side from both coils, and go not as traditionally to the secondary. I go to the primary. And also what I'm going to do is I use a capacitor. So I have not a direct connection between. I have a capacitor in between which helps me for tuning. I have channel 1 connected here, loose around the secondary, and I have channel 2 connected here to see the frequency and so on. Let's go and make some changes here. So I have to go down in the frequency in order to get something. It gets a bit noisy. It's 1 kilohertz. That's quite strong now. And I have also connected the neon here. This one is now purely illuminated from the signal generator. Let's go here to my capacitor. Hope you can hear that nicely. When I tune, you can see. Interesting, when the load snaps in, it drops in the frequency. That means Q is dropping. As well, not the frequency, sorry. Q is dropping. So that is now the bottom of the secondary, which now is supposed to go to ground, and illuminates quite nicely only from the signal generator. Let's see what we kind of, so we have a lot of radiation here, quite a lot wherever I go. Literally the whole room is radiating. And yeah, I have the amplitude set to 10%, the amp depth is 10%, otherwise it would be extremely noisy. Yeah. So that's interesting to use literally here a bipolar coil or a standard driving coil. The ratio between the driving coil and the secondary is not correct, just to let you know. It's just for me only a test. Normally the driving coil has to be much stronger built. It actually has also to carry the current, and actually then the secondary, as a TMT, the magnifier here, if you want, carries then only the voltage. So there will be on the load, top load side, would be a cable normally connected which goes to the bottom of the secondary. I have now replaced the standard primary with a bifilar for the setup. Also used frequency modulation with a FM deviation of 1%, so it's 1 kilohertz, 1 kilohertz frequency, and modulation frequency, so that gives you sound. It's now tuned at 290 kilohertz, and what you will see is the brightness of the fluorescent bulb is much higher. I have the capacitor connected. You see I can tune it here in. It's much stronger. And let's have a look here on the tuning side. Here's no story about that, but it gives you. Now let me show you how that is reflected here on the fluorescent bulb. So that is nice, bright. That is brighter, gone. Full, so that is nice, full bright. So that is much stronger output as it was on the standard coil. Here you can see that beautifully here on channel 1, the driving side, perfect. And here channel 2, the TMT. That's how it's supposed to look like. So what I have done with the capacitor in between, I make the adjustment, which is a difference between the inductance of both systems, by choosing capacitance in between, and to compensate for the gap of reactance here. and to align the mutual frequency with a much stronger output using the bifilar Tesla coil. And interesting is, radiation level is very low. That means it's a much better setup. You see it, I have to go very closely actually for much stronger output before it actually reacts, which is ideal. We don't want to have a radiator. Perfect. Let's go through here what we have here. We have on channel 2, that's 315 volt. Let's on channel 1, that's the input side, that's 38 volt. It's a factor of 8. That is quite nice. Let's have a look if we find some other frequencies. I think that was our perfect frequency. No, there's nothing coming close anymore. I think that's it. Let's tune back. But you can see here quite nicely that I can tune in and out between primary driving side and secondary. My bulb is full illuminated, and to compensate that, I can compensate that nicely. Here you can see that with the capacitor. Line set. Perfect. Okay. Start now with the standard setup of a TMT, where you have here the driving side, just normal connected to ground and lower bit, and the top side where the top LED connected goes to the bottom side of the TMT part, which is the secondary. So that would be the normal setup, and I have done here my first calibration of the system. So my lowest connectivity is here on this part you see on channel 1, that is connected over to the TMT, and channel 2 is here coming from the driving side. If I toggle over here to between channel 1 and channel 2, you see here on channel 2 I have 54 volt, and on channel 1 it's 260 volt, 280 volt. This is the improvement. Let's have a look about the magnetic field, the dielectric field. It's quite weak here. Let's see if I get, yeah, here I get something. So I give, let's see here. Yes, it's here it is. Okay, give me some indication. Now, okay, rather than going through this the setup here, it is at the moment set to sine wave. I will now exchange the primary here to the bifilar coil, and please note the value is 275, 280 on the secondary side, and 70 volt here, 54 volt on the driving side. I have now connected the bifilar coil. Please note everything on the driving side, like oscilloscope, has not changed at all. Same frequency, no adaptation. And you can see right away we have on channel 2 we have 75 volt, and on channel 1 we have 386 volt. Now let me change that now to square wave. See that? So that's what you can expect when you pulse your system. This square wave has a 50% duty cycle. That means 50% on, 50% off. So that gives you a good feeling about, let's see, I can even go higher. Let's have a look here. That gives me a tremendous amount of power boost for the same buck or the amount of energy I put in. It's partially based on the properties of the coil, but also the coupling is much stronger. So again, here channel 1 is now 584 volt and channel 2 is 100 volt. I think that's 100% improvement.